Finishing up with our last three problems, our first problem, number 13, is actually going to be one where we have to factor. And we'll get our calculator out here and go to y equals and type in a 4x squared plus 20x plus 25. And as soon as you hit graph, you're going to see something that looks very different. You don't get the benefit of clearly seeing a parabola going through one single tick mark. It looks over here, if we go 1, 2, this is at -2, over here is at -3. Sure doesn't really look like it's obviously going through one of these tick marks. Very likely it's going through just the one. And it's touching at one location. That's what we can really see. So I'm going to have a left bound of -10, a right bound of +10. Let's maybe guess at -2. You can see -2.500001 right there at that fraction. This is an instance where a parabola is touching at just one location. We also have a little bit of round off error. -2.5 with that double O, or all those zeros. You can see more or less that, the calculator's trying to tell us we're intersecting at -2.5, but that's going to happen twice. So, tell you what, how about we get a decimal converted into a fraction? Let's hit second quit. If we hit x here, again, you've got this -2.5 and so forth. Really, the calculator is trying to just give us -2.5 itself. Let's hit math frac by first just typing -2.5. If we would have tried to get this converted into a fraction earlier, it wouldn't. When you see some round off error, you're going to have to rewrite your answer without that round off. And then you have to hit math frac. You can see that really we've got x would equal -5/2. And definitely what you can see is it's the same exact answers because we crossed at that one location. Cross multiply, you'll get 2x equals -5. Cross multiply here, you'll get 2x equals -5. Add a 5 to both sides, you'd get 2x plus 5 equals 0. Do the same thing right here, and you'll get the exact same expression. When your curve crosses at just one location, you're going to get the same factors showing up. Identical parentheses, in other words. By the way, you can notice that the 4 and the 5, if you took the square root of the 4, you'd get a 2. The square root of 25, you'd get a 5. There are times when this type of factoring works out. You can see the 2 and the 5. Your signs here are both pluses rather than a plus and a minus. If you were to look at, say, number 14, and I said before that really there should be a second answer blank here. We had a little bit of an issue with that. But we could very quickly just go to y equals, clear this out. If we typed in x squared minus 25, and if we were to hit graph, you could see it sure looks like we're crossing at 1, 2, 3, 4, 5. We could get confirmation very quickly. Go to second calculate, go to 0. Type in -10 to +10. Take a guess at x equals 5. It works. We could also very quickly come over here and just go second calculate, 0. Go to -10 to 10. Certainly looks like we're going to be crossing over here maybe at -5 if you count the spaces here. Would only take a moment to confirm it, and it does. And wonderfully, these are your answers, 5 and -5. You're not asked to factor. You don't have to go through the work of, getting a 0 on the right-hand side. You're really done. Finally, as we take a look at number 15, our very last one, again, very similar. We need a new answer space here. We could get some assistance by typing out the equation, 9x squared minus a 12x, then type in a plus 4. Again, you're going to notice that it looks like our parabola is only touching at one point. That's a double answer. Your answer would be written down twice when that happens. So we could hit second calculate, go to the 0 tool. We'll guess that the left bound is -10, right bound is +10. If you look right here, we are awfully close, amazingly close to x equals 1. It's probably not a bad guess to guess that. You can see it looks like we're at 0.666665. Now, again, as we said before, if you just had x show up, and if you try to convert that into a fraction, it doesn't. The reason is there's some round-off errors. You get round-off errors when your parabola just touches at one location as opposed to two separate ones. You usually have a little bit of an issue there. You might guess that really we should be seeing 0.6 repeating. And 0.6 repeating, you could just keep hitting 0.6 and fill up the whole row here. And then just hit math frac, and you'd see that you'd get 2/3. Now, this should show up twice. This is an answer that would have two solutions. You don't have to factor it, and thank goodness you are done.